So now that we know what a compound inequality is, in this video, we're going to talk about how to solve compound inequalities. And some of the same strategies that we use for solving equations are going to apply here. So just like we lined up the equal sign, we're going to line up the inequality signs. We're going to work down the page just like we did for solving equations. We want to isolate our variable on the left because our brains and our eyes like to read it that way. We read from left to right. Therefore, it's very helpful to be certain that your variable goes to the left. And of course, we want to look out for the glitch. If you remember what the glitch is, we saw it in a video, a couple of videos back. It's when we multiply or divide by a negative. When we multiply or divide by a negative, we have to flip the inequality sign. Flip the sign, all right? And I'll remind you of that. So let's get going here. We're going to write down the steps to solve. You can write them down in your listening notebook. The first thing that we're going to do is step one. We've got to break apart and set up our inequalities. So break apart and set up. So here goes. And I'm going to highlight it so you can see what's happening here. So this is a compound inequality. Negative 1 is less than 4x minus 3, and 4x minus 3 is less than 5. So here's the first problem, and here's the second problem. Notice I'm not breaking apart 4x minus 3. It is one quantity. Don't break it apart. That's a mistake that some people make. So step one, here we go. Negative 1 is less than 4x minus 3. And 4x minus 3 is less than 5. That is step one. Break apart and set up. So step two is next. And step two is simply going to be to solve both inequalities. And that's what we're going to do next. We're going to solve both of them separately because this is compound, so we really got two problems to deal with here. Now remember, we want our variable on the left, so on this one I am going to bring this 4x over, so subtracting it from both sides using that subtraction property of equality. So now I've got negative 4x minus 1 is less than negative 3. I will add 1 to both sides. Negative 4x is less than negative 2. And the glitch is about to happen here because I am about to divide by negative 4. And when I divide or multiply by a negative, I got to flip that sign. So I'm going to highlight it because I don't want to miss it. Right down here at the bottom, I'm sort of out of room, so I am going to move to the right here. Those 4's cancel. X was less than, now it is greater than 1/2. Negative 2 over negative 4 reduces to positive 1/2. So this is the first part of my solution set. Let's keep going. 4x minus 3 is less than 5. In this side of the problem, my variable is already on the left, so I don't need to move it. I got one step here. Add 3, 4x is less than 8. I am dividing by positive 4 this time, so no need to flip the sign. 4's cancel. X is less than 2. This is an and situation. Less than, less than. This is an and situation. Our answers. Remember, anytime that we see the variable, just refer to it as our answers. So we did step 1, we did step 2, we solved them. Step 3 is to graph on the number line. Graph it on the number line, and I think I've got room right here in the middle to graph on the number line. Remember what we've already talked about? Make the number line fit your answer. It doesn't have to be the same every single time. So, but do remember left to right, smaller to bigger. So here's 1/2, and here's 2, which means that 0's down here, and 3 is up here, and then 1 is sort of in the middle there. It doesn't have to be perfect. So just a reminder, this is strictly greater than. This is strictly less than. We will have open circles because we are not including 1/2, nor are we including 2. But what is a number that's bigger than 1/2 and smaller than 2? It's 1. So this is a conjunction of sets. We're shading in everything in the middle between those two numbers. Step 1, step 2, step 3. I'm going to write them again if you missed them that time. Here we go. Next problem. This one has step 1 already done for us, because if we have an OR situation, lots of times it's already broken. So remember, step 1 is to break apart and set up. It's already done. Step 2 is to solve the inequality. So step 1 was already done for us. Step 2, let's go for it and let's solve both of these. Also nicely on this one, we've already got our variable on the left-hand side. Remember, we are lining up our equal signs, in this case our unequal signs, inequality signs, and we're working down the page. So +5, +5, 5's cancel. 3a is less than or equal to -2 + 5 is 3. This time we are dividing by +3. We only have the glitch when we multiply or divide by negative. So a is less than or equal to 1. Solve the other side. Remember, we're solving both of the inequalities because this is a compound inequality. +5, +5, 5's cancel. 3a is greater than 18. Once again, we're dividing by 3, a +3, so the inequality sign stays the same. A is greater than 18 divided by 3 is 6. This is an OR situation, one or the other. This is going to be a disjunction. This is going to be a union of two completely opposite sets of numbers. So step 3 is to graph on the number line. Step 1, break apart and set up. Step 2, solve. Step 3, graph. Make your number line work for your problem. Here's 1, here's 6. So we'll put 0 here, we'll put 5 here, and we'll put 7 over here just to make our number line look sort of nice. A is less than or equal to 1. Because we have the or equal to, we will have a closed circle on 1 showing inclusion. A is strictly greater than 6. We do not include 6. That means it's open. It's an or. We know it's going to be a disjunction. Our answers are less than or equal to 1 or strictly greater than 6. The trains are going in opposite directions. This is our graphed solution set. Here's our next problem. This one, we need to apply step 1. Remember, step 1 is to break apart and set up. So here's the break apart. Here's the first problem. And here is the second problem. Remember, this is a compound inequality, like a compound word, cup, cake, cup plus cake. Here's the first inequality. Here's the second inequality. So we're going to break them apart and do the setup. So -2 is less than or equal to n plus 2 over 3. And this is a less than, so it's an and situation. N plus 2 over 3 is less than or equal to 4. So there's step 1, break it apart, set it up. Step 2 is to solve. Solve both. Solve both inequalities. So we're going to do that. Now, even though fractions are our friends, we like to get rid of them as soon as possible. So I'm going to dump this times 3, or divided by 3, by multiplying both sides by 3. Those 3's cancel. That is by the multiplication property of equality. 3 times negative 2 is negative 6, which is less than or equal to n plus 2. Remember, when we're solving, we like our variable. In this case, it's n. We want it on the left-hand side. So I'm going to subtract n from both sides and get negative n minus 6 is less than or equal to 2 plus 6 plus 6. Negative n is less than or equal to 8. And the glitch is about to happen. Remember, this is negative 1n. So we are about to divide by negative 1. And when we divide by a negative, multiply or divide by a negative, it's going to flip that sign. So the negative 1's cancel. There's n. N is now greater than or equal to 8 divided by negative 1 is negative 8. So there's the first part of step 2 to solve the first inequality. We're going to follow the same procedure on the right-hand one. Times 3 times 3. 3's cancel. N plus 2 is less than or equal to 12. Minus 2 minus 2. N is less than or equal to 10. So our answers are greater than or equal to negative 8 and less than or equal to 10. This is an and situation. It will be a conjunction. They are going to meet in the middle. There's negative 8. There's negative 10. There's 0 somewhere around there. There's 12. There's negative 10. So both of these are going to have closed circles because they have the or equal to showing inclusion. So closed, closed, bigger than negative 8, and less than positive 10. An overlap or intersection in the middle of the number line for a conjunction for this compound inequality. Let's do it again. Not going to write the steps this time, but we are going to break apart and we are going to set up. Going to move more quickly with this one. So here's our break apart and set up. 3 less than or equal to negative 2x plus 1. And less than, this is an and situation. Negative 2x plus 1 is less than or equal to 9. So there's our setup. Let's solve both of them. We want our x, our variable, on the left-hand side. Plus 2x plus 2x, 2x plus 3, remember they're both positive, is less than or equal to 1. Minus 3, 2x is less than or equal to 1 minus 3 is negative 2. We are dividing by a positive. That is not the glitch. X is less than or equal to negative 1. Let's keep going. Minus 1, minus 1. Negative 2x is less than or equal to 8. Now we are going to divide by a negative 2. That is the glitch. X is greater than or equal to negative 4. Here are our two solution sets for our compound inequality. Our answers are smaller than negative 1 and greater than negative 4. So on the number line, remember these are negative numbers. Negative numbers get bigger from left to right. That means negative 4 has to be on the left-hand side. Think about what your number line should look like. Here's negative 1. So we are going to be closed on both of these because of the or equal to. And our answers are smaller than -1, but bigger than -4, so that's everything in the middle. Here's a 0, there's a -3, there's a -5. That kind of makes our number line look a little bit better. That's our solution set. One last problem. Here goes. Step 1, break apart and set up. Already done. Step 2, solve both inequalities. These are looking pretty simple. Divide by -5, divide by -5. We're dividing by a negative. That's the glitch. We are going to reverse that sign. -10 divided by -5 is 2. Divide by 3, divide by 3. K is greater than -3. So let's think about this. This is a very interesting problem because we're looking for answers that are bigger than 2 or bigger than -3. This is an or situation. This is a very special case because what numbers are bigger than 2 or bigger than -3? Remember, one restriction or the other has to be met. So when we put this on our number line, think about what it should look like here. So first of all, here is open on -3 and open on the 2. But if they're both greater than, nothing's going to the left. They're both going to the right. So think about it. If we take the number 5, if we let k equal 5, does it satisfy one or the other? Well, 5 is bigger than 2, or 5 is bigger than -3. That must make 5 an answer. What about if we let k equal 0? Is 0 bigger than 2? No. But is 0 bigger than -3? Yes. Remember, it's one or the other. This is not an and, this is an or. So that being said, let's take a look at one last value. Let's let k equal 2. Is 2 bigger than 2? No. But is 2 bigger than -3? Yes. And as long as it validates one or the other, it's in the solution set, which is why we just have that. That is a special case for you to think about. That is compound inequalities.